What is oceanography?
Oh, such a great question.
This is Lisa. She's an oceanographer, and she studies the mysteries of our oceans.
So the oceans are 70% of the planet. Because we live on land, we don't think so much about the oceans, but they're most of the planet. So planet Earth could probably be called planet water. Within that big mass of oceans, we actually do a lot of different kinds of science. There's physical oceanography. We think about how water moves around. There's biological oceanography, so all the living things that are in the ocean. And there's chemical oceanography, so paying attention to individual chemicals. And then we have geological oceanography that really deals with anything that's happening on the sea floor and down into the center of the earth as well. So oceanography is many things. It's really a study of a particular part of the planet.
Why should humans care about the ocean?
Because it's so cool and amazing. And sometimes it's literally cool because we have polar oceans. And let's start with all the amazing things that the ocean provides. So obviously, if you like seafood, it's a really good resource. And I think actually maybe on the order of 25 to 30% of the protein that humans eat actually is associated with the ocean. So absolutely we want to understand and be able to make wise decisions about the ocean ecosystems because humans rely on them for food. We have transportation on the ocean, right? So that was really how you got from continent to continent, and that still happens quite a bit. There's a lot of critical minerals and things like that that are found there. So on the human side, there's a lot of reasons to study the ocean. The ocean can be a challenge on occasion, right? So we want to study the ocean for our ability to predict storms. That obviously are going to impact humans, and can we get the forecasts better and better, and can we make predictions that then tie to the atmosphere? Like the ocean has done a lot of favors for us. 90% of the excess heat from climate warming actually is stored within the ocean. So we also absolutely have to study the ocean for Earth systems understanding. I spent a lot of my early career going out to sea, and it's amazing when you're out in an oceanographic cruise. And the NSF actually has what we refer to as the academic research fleet. So we have about 18 different ships that go around and support U.S. science and go everywhere from the Arctic Ocean to the Southern Ocean and all the areas in between. So we certainly still use a lot of ships. Satellites, we can learn a lot looking down onto the planet, but often the satellites can only tell us about sort of the skin of the ocean. They can't really see through water. Water presents challenge. Salty water presents even more challenges. All of the information that's going back and forth via undersea cables, we're starting to realize we can learn some things from the cables. That cable goes out to an undersea volcano. And so we're pretty good at predicting when this particular undersea volcano is next going to erupt. So this cable piece is really giving us some amazing ways to do oceanography. We have these amazing things that have changed the world of how we do oceanography called Argo floats. And those can be out for several years, and they basically float around the ocean, and every 10 days they take a profile, again, of that temperature, salinity, and they tell us what depth they're at, because it's really important to pass along information about, well, what temperature is it? Well, it matters as to what depth, what we're interested in. And these guys are going down to 2,000 meters. So, sort of miles of information are coming back, and they float up to the surface, phone home. E.T. home phone. And basically give us the information every 10 days, and we have these Argo floats throughout the world's ocean. So that's really changed quite a bit on the physical oceanography. And that is those challenges, right? We don't have an unlimited number of ships. So the ships are doing really important stuff, but they're out there in one spot for one period of time. But most of the ocean is 2 miles deep. So we got to go down and understand all of these really important areas. But it's pressure. So what I have here are actually styrofoam cups that made journeys to the bottom of the ocean. So this cup here is about 3,000 meters in depth, and that was up in the Arctic Ocean. So that's your full-size styrofoam cup shrunk down. This guy here was in the Puerto Rico Trench. That's over 5,000 meters. Look at how shrunk down those styrofoam cups get. So it's really technologically challenging to understand what is the environment of most of the ocean. It turns out that they're really good at recording the history of the Earth. So paleoceanography, we have specific kinds of ships that go back and take cores, so essentially long tubes of mud through the sea floor, and that's like looking back in time. So we can go back and look at what did the oceans look like when the Earth was much warmer? What did the oceans look like when the Earth was much colder than it is now? And we have fossils within those sediments, usually really teeny tiny fossils, microfossils, but we can use some of their skeletons to also talk about or figure out what the temperature, what the salinity might have been in those past periods from the ocean sediment. Our fish ancestor tetrapods kind of went, oh gosh, we can colonize, and you got to have a few things like, lungs and a few other things.
Life finds a way.
Honestly, all things with backbones crawled out of the ocean, but the plants had to develop the vascular systems, but it came from things sort of crawling out of the ocean. And then some things crawled back in. So did you guys know whales, we think, actually went back into the ocean and are related to wolves? So we kind of had the fish crawling out and giving rise to all of the vertebrates. So I do think about this kind of stuff, right? Like, I'm like, if we had one of those breathers like they have in that Star Wars episode, like I think it's episode 1, right, where they go hang out with the Gungans, would that make the planet so much better? And I think it is that exploration piece, right? Like, it is 70% of the Earth. So we really don't understand, we don't protect, we don't own most of the planet when it comes to that. So I think there's an inherent desire to think about humans out there. I think we all do kind of have that hankering for what could we do if we colonize. And I think, can we get to a place where humans are sort of using in a good way, in a sustainable way, the oceans in ways that we haven't thought about? So those lovely little breathers from Star Wars, I think, there's other, Atlantis.
Now, some of you may ask, why Atlantis? It's just a myth, isn't it? Pure fantasy.
Right? We all go look for Atlantis. And we certainly, as the ice sheets have come and gone, we have had cities that have essentially been overrun with oceans. There's some excitement and joy and all of that, but we have to be careful about how we're treating the ocean and get back to that sustainable development. But it's the love of the unexplored, I think, and it's great to think about, could we be part of the ocean as well as part of the land on the planet?